Hi everyone. I hope you guys are doing really great. So today I'm going to talk about how to create a one-way ANOVA using SPSS. So this one-way ANOVA has a lot of applications in different kind of streams like biology, economics, chemistry, you name it. Every field has some kind of application in one-way ANOVA, because in most of the times when you are doing a research, you are collecting data. So in order to analyze those data, one of the most commonly used techniques is the one-way ANOVA. So in one-way ANOVA, your response variable should be a numerical variable, and your independent variable or your predictor variable should be a categorical variable. So in SPSS, in order to analyze the one-way ANOVA, your data layout should be like this. That means you should have a one column which consists of the numerical values, and you have another column which consists of the levels of your categorical variable. So if your data set is not in this form, first you need to convert your data set into this form. So this data set contains the sodium content of 4 bands of turkey. So you can see there are four brands of turkey, and the first column, the sodium content, represent the sodium content of each band of turkey. So basically in one-way ANOVA, we are testing this hypothesis. The null hypothesis is that we are checking whether the population means of all 4 categories are equal, or our alternative hypothesis is at least one category has a different mean. So that is our null hypothesis and our alternative hypothesis. So we are going to test this hypothesis by using a one-way ANOVA. So first, in order to do a one-way ANOVA, first we have to do is you have to enter the data like this and go to analyze, then select compare means, and here choose one-way ANOVA over here. Then you will see this window. So here under the dependent list, you should choose your response variable, basically the numerical variable in your variable list, as your dependent variable, and as your categorical variable or your factor variable, you should choose as your categorical variable. So you should choose this one as a factor variable, and after that you need to do some Posthoc tests. Like sometimes you might need to see which brands are significantly different and which brands are not significantly different, and if you want to check whether the model assumptions are satisfied. So in that case you need to check or you need to select some options. So first go to options over here, and here if you need to get some descriptive statistics, so just select this descriptive. And here if you want to see, check the homogeneity of variance, that means the constant variance assumption is satisfying or not, you can check this option. And if you want to check the mean plot of this data, then you can check this option. So after selecting the things that you need, then choose continue. After that, here under the Posthoc test, you can choose the option that you need to consider. Since here I am assuming the constant variance assumption, I'm going to select one of the options from here. I'm going to, since I'm going to test the all pairwise comparisons, I'm going to choose this Tukey or two-key comparison test from here. Then after that you need to choose continue, and after that you need to choose OK. Alright, so this is your output. So this is the main output, your ANOVA output. So here all the other results are heavily depend on this. That means if the p-value of this F statistic is not significant, then there is no point of looking at the other outputs. So first you have to see this ANOVA output over here. So here you can see your sums of squares. This first one is sums of squares of regression, and the second one is sums of squares of error, and this third one is your sums of squares of total. And here they have calculated the mean square value, the mean square regression, and mean square error, and dividing mean square regression by mean square total, you can get the F statistic, which is 294.501. and you can see this is very large, so that implies the p-value of this F statistic is very slow or very small. So that implies what? Since the p-value is very small, close to 0, you can reject this null hypothesis and tell at least one mean of these 4 brands. So here we tested the mean of 4 brands. So here, based on this result, we can say that at least one mean is significantly different from others. So in order to identify which pair of bands are significantly different, you can use this multiple comparisons output from over here. So here you can see basically the all not all actually. So here you can see here the first you have the brand 1, brand I corresponding to the first brand, and here brand J corresponding to the second brand. So this first row implies the mean difference between the brand 1 and brand 2, and here you can see the mean difference is 72.7 and the standard error is 2.82, and the p-value here is 0. That means what? Here we are testing the null here we are testing the null hypothesis, whether this whether there is a significant a null hypothesis. There is no significant difference between there is no significant mean difference between brand 1 and brand 2, and our alternative hypothesis is there is a significant difference between brand 1 and brand 2. Since the p-value is small, we can reject the null hypothesis and conclude that there is a significant difference between brand 1 and brand 2. Similarly, we can see that there is a significant difference between brand 1 and brand 3, also between brand 1 and brand 4. Likewise, here you can interpret the other result as well. So this is about multiple comparisons. So basically we are looking at this if this if this F statistic is significant. If this F statistic is not significant, then there's no point of looking at these outputs. Okay, so this is about the homogeneity of variance. That means the one of the assumptions in ANOVA is that the residuals have a constant variance. So since we are looking at the mean, you can see here they have calculated this 11 statistic which is 0.465 with a p-value of 0.709. So here our null hypothesis is that the variances are equal among 4 groups, and our alternative hypothesis is variance are different. That means at least one group has a different variance. Since here the p-value is large, that means we cannot reject the null hypothesis. That means the variance is equal among the 4 groups, so we can assume the homogeneity of variance. So here they have given you a mean plot. So based on this mean plot also you can see, you can get a clear picture whether the means are equal or not. So here you can see this, the mean of the first group is significantly greater than the mean of the other 3 groups. That implies basically the brand 1 is significantly different than the other 2. And based on this you can see that brand 4 is also clearly significantly different than the other 2 groups, other 3 groups. But based on the mean plot, we can see that the mean belongs the mean of brand 2 and brand 3 is somewhat similar. So that means there seems to be no significant difference between there is no significant difference in mean between brand 2 and brand 3. Alright, so this is how to interpret your ANOVA output if you use SPSS. So if you think this video is useful to you, just put a like on my video, and if you want to see more videos like this, please subscribe my YouTube channel. Thank you very much and have a nice day.